Hello class, we will again continue with our lecture video series in Differential Calculus. Now, our lecture today is about polynomial curves and how to get the tangent line and the normal line at a point indicated. So here in the figure, you see a circle with the equation x squared plus y squared is equal to r squared. Now in this circle, at any point P, we will be having a tangent line and a normal line. So what are these tangent line and normal line? At a point P, in our circle, point P with coordinate x, y, here, we will be having a tangent line. Tangent line is defined as a line intersecting the circle at only one point. Now in that tangent line, this blue line here, we can derive a normal line. So this normal line will be intersecting the tangent line at a perpendicular angle, or that is 90 degrees. Okay? Thus, the slope of tangent line is defined as the slope m, whereas the slope of a normal line is defined as the negative reciprocal of the slope of the tangent line. And for us to get the equation of the tangent line and the normal line, we will be using the point slope form. Okay? So that is y minus y1 equals the slope times x minus x1. So the y1 and x1 here is actually the point or the coordinate at which the tangent line and the normal line intersect. So that this is your x1 and this is your y1. Okay? So let's answer the exercises. So the question is, or the exercises here is, find the equation of the tangent line and the normal line at the point or points indicated. Now here in our example 1, we have the equation or the curve y equals x raised to 3 minus 3x squared minus 2 at the point 1, negative 4. So as defined earlier, this point here, this point P is intersecting the, or this point P is at the curve which has the tangent line and the normal line. So this point P here is actually your x1 and y1. Okay, point P, x1, y1. Okay, so what are the steps? The first is to, since we have our x1 and y1 already, remember that we will be using the point slope form. So the point slope form here is y minus y1 equals the slope, then x minus x1. So we already have our y1 and x1 as given by the problem already. So we will be looking for the slope, m. Now how do we determine the slope of this equation? Obviously, we will solve for the y prime, because if you recall, y prime is also the slope. So let's derive the equation. Y prime is equal to 3x3 minus 1 minus 3 2x2 minus 1 minus 0. Okay, so y prime is equal to 3x squared minus 6x. Now how do we determine now the y prime? Remember that the point is already given. At point 1, negative 4, your y prime is now equal to 3 times 1 squared minus 6 times 1. So this is 3 minus 6. Therefore, y prime is now equal to negative 3. So this is the slope of the tangent line. So that is the slope of the tangent line. Now for tangent line, using the point slope form y minus y1 equals m x minus x1, then knowing that y1 is equal to negative 4, the slope m is negative 3, x minus x1 is 1. So let's just simplify this and we will be getting our equation. So negative 3 x minus 1 y plus 4 equals negative 3x plus 3. Therefore, this is 3x plus y equals 3 minus 4. So we have 3x plus y equals negative 1. So this is now the equation of tangent line. Okay? So using the point slope form, we were able to get the equation of the tangent line. Now for the normal line, so this is for the tangent line. For the normal line, again, how did we define the slope of the normal line? The normal line is negative reciprocal of the slope of the tangent line. So here, your slope for normal line is equal to negative reciprocal of the slope of tangent line. So that is equal to negative 1 over negative 3. And that becomes 1/3. So 1/3 is the slope of the normal line. Then again, using the point slope form, y minus y1 equals slope x minus x1. Then our y1 is negative 4. The slope of the normal line is 1/3. Okay. This is y plus 4 equals 1/3 x minus 1. Then multiplying both sides of the equation with 3. So in the right side, we will be cancelling out 3. Then in the left side, distribute the 3. So we have there 3y plus 12 equals x minus 1. Simplify further. So we have negative x plus 3y equals negative 1, negative 12. So negative x plus 3y equals negative 13. So this is now the equation of the normal line. Or, you can have it positive x minus 3y equals positive 13. Just distributed the negative. So either of these two can be used and they are still the same. They are all equation of normal line. Okay, so that's how you compute for the equation of the normal line and the tangent line. So basically, in this example 1, all we did is look for the value of the slopes for the tangent line and the normal line, because the y prime and y1 and x1 is already given. Alright, so let's proceed for example number 2. Okay, so example number 2. Again, what is our formula or pattern? Y minus y1 equals mx minus x1. So obviously, in example number 2, we still have to look for the slope m. What else is missing in example number 2? Now, for example number 2, the only given here is the x1. So, given the equation of the curve, y equals quantity 2x minus 1 raised to 3 at x is equal to 1, meaning the curve is being intersected by a line x equal to 1. So, we have your x1. So, what is missing for the point slope form to be completed? We need to find y1 and the slope. First, we will be looking for the y1. How do we get the value of y1? Well, simply, we just substitute the value of x to the original equation. So, the value of x here is 1. So, we have there 2 times 1 minus 1 raised to 3. So, y now is equal to, this is 2 times 1, 2. 2 minus 1, 1 raised to 3. So, y is equal to 1. Therefore, the point here is at 1, 1. So, we have our x1 and y1. Okay? After getting the value for y1, the next one will be your y prime, your slope. So, to get the slope, we have to derive the original equation, so y prime. So, we have there 3, the base, 2x minus 1, 3 minus 1, and don't forget the derivative of the base, the one inside. So, we have there 2x, derivative of 2x is 2, derivative of 1 is 0. So, y prime is now equal to 3, 2x minus 1 raised to 2 times 2. Y prime is now equal to 6, 2x minus 1 raised to 2. Now, to get the value of y prime, we substitute the value of x. So, y prime is equal to 6, 2 times 1 minus 1 squared. That is equal to 6 times 1 squared. Therefore, y prime is equal to 6. Since we have our y prime equal to 6, m of tangent line is now equal to 6. So, we have now all we need. We have our y1, x1, and the slope. So, for the tangent line, for the equation of the tangent line, using the point slope form, y minus the value of y1 is 1, the value of slope is 6, x minus the value of x1 is 1. So, we have there y minus 1 equals 6, x minus 1, y minus 1 equals 6x minus 6. We have negative 6x plus y equals negative 6 plus 1. So, we have there negative 6x plus y equals negative 5. This is now the equation of the tangent line. Or, we can have it 6x minus y equals 5. So, these are all equation of tangent line. So, whichever is your answer, the first one or the second one, it's still the equation of tangent line. Now, how about for the normal line. So defining the slope of normal line as negative reciprocal of slope of tangent line. So we have the negative 1 over 6. So using the point slope form, so y minus 1 equals negative 1, 6, x minus 1. So y minus 1 equals negative 1, 6. Then multiplying both sides of the equation with negative 6. So we will be cancelling this one out. The other one will be distributed. So negative 6y plus 6 equals x minus 1. Then we have there negative x minus 6y equals negative 1, negative 6. Negative x minus negative 6y is equal to negative 7. So this is now the equation of the normal line. Or you can have x plus 6y equals 7. Just distributed the negative sign. So whichever is your answer with these two, still it is the equation of normal line. Okay, so we can have two answers, but they're still the same equation. Next, let's solve for the example number 3. Given the equation of a curve y equals x squared minus 2x at point of intersection with line y equals to 3. So given now your y1, so what's missing is the slope and the x1. So if you're familiar with this equation, this is actually the equation of a parabola. How? Well, if we put y, the value of y here in this equation, this becomes 3 equals x squared minus 2x. This becomes now x squared minus 2x minus 3 equal to 0. Now if we plot this, curve, okay, given this original equation, we will be having a table given y, this is x. If y or if x is equal to 0, we value here 0, the answer for y will become 0. If we put the value of 1 on the x, so this one is 1 minus 2, then the value of y becomes negative 1. If we put the value of 2 with the x here, so this becomes 4 minus 4, so what happens? So if 2 is the value of x, y will become 0. Okay, now if we put the value of negative 1 here, so what happens? This becomes 1, and then this becomes positive 2. So what happened there? This is negative 1. This becomes 3. Then if we put the value of negative 2 and the negative 2 here, this becomes 4, then 4. This becomes 8. Then if we put the value of 3 here, the x, if x is 3, so this becomes now 9, then it becomes 6. So what is 9 minus 6? Becomes 3. So plotting here in our x and y coordinate, 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 1. So 0, 1, negative 1. So you have there y negative 1, then positive 1 here for the x. So let's have a different color. Okay. Then we have there 2, x is 2, y is 0. If x is negative 1, y is 3. If x is 3, y is 3. And then the given y is equal to 3 is actually a line here. This line here is your y equal to 3. And then connecting all points here forms now the parabola. So if you observe, it says there in the problem, y equals x squared minus 2x. So this is the equation, y equals x squared minus 2x. And at a point of intersection with line y equal to 3. So if that line y equals to 3 intersects the parabola, so if you observe, we have here 2 points. The points P1 and then P2. Okay? So the point P1 has a coordinate, what? The point P1 here, the point of intersection, is negative 1, 3. And the point 2, P2, has the intersection 3, 3. So these are our coordinates. So we will be expecting how many tangent lines? So we will be expecting two tangent lines, meaning the line intersecting the parabola at a singular point. So this is a line, so it will be continuous. You cannot consider the line y equals to 3 as a tangent line because it is intersecting the parabola at a 2 point. So that this line here of y equals to 3 is not considered as a tangent line. Rather, we will be looking for the pink line here. That is your tangent line. This is your tangent line 1, tangent line 2. Now, if we have 2 tangent lines, we will be expecting also what? We will be expecting 2 normal lines. So, we will be looking for normal line 1 and normal line 2. Okay? So since we were able to locate or to pinpoint that there are two tangent lines, therefore we can expect that there are 2 normal lines. Okay? Now we can actually determine also the points without plotting the curve. So how do we do that? So if you prefer solving for the point without plotting the curve, we can also do that. So how? Solve for P1 and P2 at y equal to 3. Now to solve for that, the original equation is y equals x squared minus 2x. Put or substitute the value of y. We have there x squared minus 2x. So we have there x squared minus 2x minus 3 equals 0. So the roots of this is x plus 1 because so how do we arrive with the x plus 1 here? So what two numbers will you multiply with so that the answer will be negative 3, but if you add it, the answer will be negative 2. So that will be negative 3 times 1. Negative 3 times 1 becomes negative 3, and then negative 3 plus 1 becomes negative 2. Okay? Or you can also use the quadratic equation formula to determine the roots. So this one here is x plus 1 and then x minus 3 equals to 0. Therefore, the roots here are x equals to negative 1, x equal to 3. Therefore, P1 becomes negative 1, 3, and then P2 is 3, 3. So, still, the points that we determine from the sketch is the same. Okay, so having been determined the points, coordinates, we will now solve for the next one, the slope. So having y1, y2, and then x1, x2, the next one will be the slopes. Okay, so we can then expect that the slope for the P1 will be different with the slope of P2. So let's solve for first the P1. At P1, negative 1, 3, let's have the slope. So as I have said earlier, the slope for the point 1 will be different from the slope of the point 2y. If you observe, the line, the tangent line here in the drawing is moving downward, whereas tangent line 2 is moving upward. So they are two different slopes. So for y, y prime is now equal to 2x minus 2. The original equation is y equals x squared minus 2x. So we derive y prime is equal to 2x minus 2. Then substitute the value of x, negative 1 minus 2. So negative 2 minus 2. Y prime is negative 4. Therefore, slope of tangent line 1 is equal to negative 4. Using that slope, we will be having the tangent line. Y minus y1 equals m1 x minus x1. Y minus the y1 here is 3. Then slope of negative 4. X minus x1 is negative 1. Y minus 3, negative 4. X plus 1, y minus 3. Negative 4x, negative 4. 4x plus y equals negative 4 plus 3. Therefore, 4x plus y equals negative 1 is your equation of tangent line 1. Next, we will be determining the equation of the tangent normal line 1. For normal line 1, slope negative 1 over slope of tangent line 1, negative 1, negative 4. Therefore, the slope of normal line 1 is 1/4. So we have there y minus y1 equals m1 x minus x1, y minus 3 equals 1/4 x minus negative 1 x plus 1. Then multiply both sides of the equation with 4 so that we can cancel out the 4 in the right side. Then distribute the 4 on the left side. We have now 4y minus 12 equals x plus 1. So negative x plus 4y equals, this becomes 12 plus 1. So we have there negative x plus 4y equals 13. Or we have there x minus 4y equals negative 13. So you can have either of these two. They're both equation of normal line 1. Okay, now that is for the point 1. We still have the point 2. Now for the point number 2, so at point 2, which is our point 2 here is 3, 3. Again, we will be looking for the slope. So a while ago, we were able to get the y prime equals 2x minus 2. This time, let's substitute x with 3 minus 2. This becomes 6 minus 2. Therefore, y prime is equal to 4. The slope of tangent line is now equal to 4. So if you observe, the slope for tangent line 2 is different with the slope of tangent line 1. So the tangent line 1 has a slope of negative 4. Then tangent line 2 has a slope of 4. Okay, so using that slope, we now have, this becomes 2y2 m2 x minus x2. y2 is 3, m2 is 4, x minus 3, y minus 3, 4, x minus 3, y minus 3 equals 4x minus 12, negative 4x plus y equals negative 12 plus 3, negative 4x plus y equals negative 9. So you can have this, or we have 4x minus y equals 9. So either of these two, they are both equation of tangent line 2. So that is 4x minus 9. Now how about slope of normal line 2? It is negative reciprocal of slope of tangent line 2. Negative 1/4. Okay, so that is negative 1/4 slope. Y minus 3, negative 1/4. Then multiply both sides of the equation with negative 4, so that we can cancel out negative 4 here. Then distribute negative 4 on the other side. 4y plus 12 x minus 3. This becomes negative x minus 4y equals negative 3, negative 12, negative x minus 4y equals negative 15. Or you can have x plus 4y equals 15. So either of these two, they're both equation of normal line 2. Okay, so that is for the example number 3. So again, you can sketch the curve to get the point, or you can just simply solve it, whatever easier means you find. Okay, I will accept that. Next, for the example number 4. So for example number 4, we have there a rather more complicated equation. This is a curve, quantity x minus 3y squared plus 8x plus 12 equals 0. And we will be looking for the tangent line and normal line at point negative 2, 0. So, as you can see, we already have here x1 and y1. So, there's no need to solve for these two because it's already given. And knowing that there's only one point here, therefore, we only have one tangent line and one normal line to solve at this point. So, what else is missing? We will be looking for the slope. To solve for the slope, we will be solving for the value of y prime of the equation. So solution, we have there bring down 2, copy the base, you recall this portion. So if you observe, this is going back to the topic of implicit differentiation. 2 minus 1, then derive the base. We have there, what is the derivative of x? 1. Minus, what is the derivative of 3y? So y here is dy over dx. So this becomes 3y prime. Plus 8. Plus 0 equals 0. So this is 2x minus 3y. Y minus 1 minus 3y prime plus 8. And we have 2x minus 6y, 1 minus 3y prime plus 8. Then distribute, we have there 2x minus 6xy prime minus 6y plus 18yy prime plus 8 is equal to 0. Then, what we have learned from implicit differentiation is to leave all y prime in the left side of the equation. So, we have there negative 6xy prime plus 18y prime equals negative 2x plus 6y minus 8. Therefore, we have there y prime negative 2x plus 6y minus 8 all over negative 6x plus 18y. Now, substituting the value of x and y, we have here y prime equals negative 2. The value of x is negative 2 plus 6. The value of y is 0 minus 8 all over negative 6. The value of x is negative 2 plus 18, the value of y. Cancel this one out. It's already 0. Therefore, this is negative, no, it's already positive 4 minus 8 all over positive 12. Negative 4 over 12, therefore y prime is negative 1/3. The slope for the tangent line is equal to negative 1/3. Okay, so that's all for solving for the slope of the equation at point negative 2, 0. Now, let's input that in the equation. Y minus y1 equals mx minus x1. And then our point there is negative 2, 0. So y is 0 equals the slope is negative 1/3. X minus negative 2. So y equals negative 1/3 x plus 2. Multiplied both sides of the equation with negative 3 so that this one is cancelled. Then distribute negative 3 on the other side. So we have there x plus 2. Negative x minus 3y equals 2. That is your tangent line, or we have there x plus 3y equals negative 2. So either of these two is the equation of tangent line. Now for the normal line, we have the slope, negative reciprocal, negative 1 of negative 1/3. So what happens with that? Negative 1 1/3. Now this portion here, we apply the fraction rule. Negative 1 1 multiplied by the inverse of the denominator. The inverse of the denominator is negative 3 over 1. So multiplying this portion with this one, what happens? The answer here is 3. Going back, the answer for this will become 3. The slope for the normal line becomes 3. X minus x1, y minus 0, 3, x minus negative 2, y equals 3, x plus 2, y equals to 3x plus 6, negative 3x minus y, plus y equals 6. That is the equation of the normal line, or you can have 3x minus y equals negative 6. So these are the equation of normal line. So that's for the example number 2. Okay, now for the example number 5, we have the seesaw. The equation of the seesaw is y squared equals x raised to 3 over 2a minus x. and we will be looking for the tangent line at the point, the normal line of the point A. So we will be having point AA here. So A as constant. So having x1 and y1 already, we now have the idea that we are only looking for one tangent line and one normal line. So all we need to do now here is to solve for the slope. To solve for the slope, we will be looking for the y prime of this equation. Okay? So let's derive. This becomes 2y prime. Oh, for easier solving, let's have it x raised to 3 and then 2a minus x raised to negative 1. So this equation here is still the same as the equation there. Okay. Now we have there 2y prime equals x raised to 3. So we are doing derivative of a product. So if you recall, the derivative of, so d dx of uv, so u derivative of v plus v, oh this is v derivative of u. So we have here x raised to 3 as the u, then let's derive the v. So bring down negative 1, copy the base, minus 1, the exponent, then derive the base. Derivative of 2a with a as constant, that becomes 0. Derivative of x, that is 1. Then, don't forget, we still have the second term plus v du, v derivative of u. So v here is 2a minus x raised to negative 1. And the derivative is 3x. This is 3 minus 1. Then simplify to get the y prime. 2y prime. So actually this is negative 1 multiplied with the negative 1 here. So it will now become positive. So there's no need for the negative 1 there. So what's left here is 2a minus x negative 2, then plus 3x squared 2a minus x raised to negative 1. Then we have 2y prime is equal to x, so this is x raised to 3 all over 2a minus x squared, because we put already the numerator into the denominator, so the negative sign of the exponent becomes positive, plus 3x squared all over 2a minus x. Now, there's no need to simplify this further because we can already substitute here the value of x and y. So at AA here, we have now 2 times a y prime equals a raised to 3. 2a. This is just to make it simpler. 3a squared 2a minus a. Then 2a y prime equals a raised to 3. 2a minus a is a squared plus 3a squared over a. Simplify. So a raised to 3 divided by a squared is a, plus 3a squared divided by a, that is 3a. 2ay prime equals 4a. Y prime is equal to 4a over 2a. Y prime is now equal to 2. So, if y prime is equal to 2, therefore, m of tangent line is equal to 2. So, having the value of slope of tangent line, we can now proceed to the point slope form. Y minus y1 equals m x minus x1. Y minus a equals 2 x minus a. Y minus a equals 2x minus 2a. Negative 2x plus y equals negative 2a plus a. So we have negative 2x plus y equals negative a. Or we have positive 2x minus y equals a. So either of this is the equation of tangent line. Now for normal line, m of normal line is negative reciprocal of m of tangent line, negative 1/2. So y minus y1 equals m x minus x1. Then multiply both sides of the equation with negative 2 so that we can cancel out this and distribute the other side. Negative 2y plus 2a equals x minus a. So we have there negative x minus 2y equals negative a minus 2a. Negative x minus 2y equals negative 3a. Or this is x plus 2y equals 3a. So either of this is the equation of normal line. Okay? So that's how to solve for the equation of tangent line and normal line for example number 5. Now for the rest of the exercises, we will have a part 2 of this solving. Okay, so stay tuned for the part 2 and 3 so that we will solve the sample problem given in your differential calculus handout. So that's all for today. Stay tuned for the rest of the lecture series. Thank you.